Hello everyone, welcome to my presentation on credit card fraud detection. Here in this presentation, I'll be covering 5 different aspects regarding this project. So, first aspect I'll be covering is the raising fraud root cause analysis. Then I'll be talking about the structured problem solving. Then I'll talk about the PPT presentation. Then I'll talk about the code that are used for the model building. Then at the end, I'll talk about the cost benefit analysis. Okay, so let's start with the rising fraud root cause analysis. So in this, as you can see from the graph or picture, that I've shown like different aspect due to which the fraud cases are rising. So the first reason is basically merchant do not follow these strict sanity check, and also they use non-secured payment gateways that are third parties. And also sometimes what happens is we fail to identify fraud transactions so that we can take action against those transactions. And this can be reason because sometimes the customer don't report fraud transaction to the bank on time. It can be because customer don't have proper um, helpline to report the issue, or they don't have the access to the nearest branch to report the issue where the fraud has been taken place. It can also be the reason because sometimes banks don't spend much on infrastructure and security. Because of that, they don't have a proper ML learning model to automate this thing and detect the fraud detections through credit cards. And also sometimes bank don't send alerts or notify the customer regarding the fraud transaction. It's not because sometimes bank don't have phone verification of the customer, and also sometimes the ATMs, POS terminals don't have proper OTP system available. Next, I'll talk about the structured problem solving. In the structured problem solving, what I've covered is basically 5 different set of questionnaires, and I'll discuss one by one. These are basically I've done before the model building so that it will give me a fair amount of idea while building the model as to what can be the reason for fraud transaction, different aspects of the fraud transactions. So first is basically who is involved in the process. The people involved in this process are basically end user credit card holders, banks, merchants, payment gateways, and scammers are the fraud people who do the fraud transaction. The next is what do they do with it. These scammers or these fraudsters, basically what they do is basically transfer the money from the end user account to their own personal account for their personal use. Also sometimes they hack the end user account and get the sensitive information from the user's bank account and credit card. Also sometimes they withdraw the amount from the end user account to generate reward points and convert these reward points into cash, or also cancel purchase of some product or make some purchase of the product based on their convenience. Where do this fraud happen? This basically fraud happens when while making transactions at the ATM, while making payment through like through a credit card at a public place such as mall, shopping complex, restaurants, etc. And also like while we are trying to make online shopping through third-party website that is non-secured, or sometimes trying to do the UPI payment, and also sometimes when you're trying to transfer the money to the another account, maybe while doing that maybe we have transferred account money to some another account that is not known to us. So this is also the case. When does it happen? This basically happens when our credit card is stolen, or when we share our personal or private information regarding the credit card to spam calls or spam emails, or sometimes by mistakenly when we select repeated billing option for our recurring payments. Also sometimes when we make payment through a non-secured payment gateway, or also when you're trying to make payment to a website and through a website for some shopping, and we save our details of the credit card for future payment. So how is business affected by this? The business affected by this in such a way, like whenever a fraud is reported, the end user may file a legal action against the bank, and this will result in a huge penalty paid by bank, as a result of which there is a financial loss to the bank. And also sometimes in the fraud transaction, um, the bank block the lost card of the customer and issue a new card. So in that case, there's an extra financial burden in the bank. And also, like due to this fraud transaction, there's the legal trust between the bank and the end user is broken, and because of that, there can be attrition of the existing customer associated with the bank. Also, this will dent the image of the bank on the global level. Okay, now let's talk about the so in this presentation we'll talk about the goal, goal, the problem statement, the business goal, the data cleaning methodologies, EDA plots from where we draw some insights, different models, their accuracy, best model, some recommendations, conclusions, and do the cost benefit analysis. Okay, let's start with the presentation. So introduction. So basically our goal is to build the most accurate model to detect the maximum credit card fraud transaction. We also detect the different types of transaction and their trends, as this will help us to know like which type of transaction and which merchant has reported maximum fraud transaction by the customer. Or maybe from this we can say that whether like what type of people are more prone to fraud transactions. So this is what will help in do the further analysis. And also like we'll perform the cost benefit analysis to check the final saving with the help of cost incurred before and after the model, so as to know like the amount where we are if we are spending on the building the model, in return will saving our cost or not. Okay, so now let's talk about the problem statement. The problem statement is like we have to help Finex to detect fraud transaction and the business impact of these fraud transaction. To do that, we'll build a most accurate model to detect the maximum credit card fraud transaction, so as to reduce the number of fraud transactions in future. For this, we'll identify the driver variables and understand their significance, and as these will be strong indicators of the fraud transactions. So for this, we'll identify the plots and outliers if there are any in the data set, and also we'll check for the data imbalance and the skewness in the data, and we'll fix it accordingly. We'll also cover the technical and the business aspect while building these models. Then in the end, we'll summarize the fraud detection by using predictions, by using evaluation metrics like accuracy, sensitivity, specificity, and precision, and also perform the cost benefit analysis to check the business impact of these fraud transactions. So the business goal is basically Finex company want to develop a machine learning model to detect a fraud transaction based on historical data of the customer with a pool of merchants. Finex want to analyze the business impact of these transactions that are fraudulent and recommend the optimal ways that the bank can adopt to mitigate the fraud risk. And also the company want to know the benefit of the model using the cost benefit analysis. So methodology 1. Here first we'll do the data exploration. In the data exploration, we are provided with the two data set, fraud train and fraud test. And this data set contains all the information about the fraud transaction generated through various sources and their activities. So here the train file contains 1296675 rows and 23 columns, and the test file contains 555719 rows and 23 columns. Out of the 23 columns, 10 are numeric columns and 13 are non-numeric column or categorical columns. So now for the better analysis, we have merged the train and test dataset into a single dataset, that is credit card fraud CV for model building. Now this merged data set now has 1852, 394 rows and 22 columns. Out of 22 columns, 10 are numeric columns and 12 are non-numeric or categorical columns. Now let's talk about the data cleaning and preparation. Before the data cleaning, we check like what are the different data types present in the data set. As you can see, there are different types of variables present in the data set, and there are different types like transaction date, transaction time, CC num, merchant, category, amount, gender, street, etc. etc. Now, first of all, we'll check the shape of the data and the data types in the data set. Then we'll check for the null values. We'll convert this incorrect data to the correct data types for better result. We'll bin the columns for better analysis. We'll create some new columns. We'll drop the columns that are not useful for the analysis. We'll check and handle the outliers in the data set. Then we'll check for the null values. We'll reduce the columns that are not available for the not required for the analysis. We'll check and handle the outliers in the data. Solution methodology, EDI and findings. So for the EDI and this, we first of all do the univariate analysis, value count, distribution of variables. Then we'll do the bivariate analysis, correlation coefficient, pattern between the variables, etc. We'll use the oversampling techniques to fix the data imbalance if it is there, and we'll use this feature scaling and dummy variables and encoding of the data. We'll fix the skewness of the data if it is there, and we use classification technique like logistic regression, decision tree, random forest used for model making and predictions. And we'll do the validation of the model presentation, conclusion of recommendations, and perform the cost benefit analysis. So first we'll check for the outliers. As you can see, there are no outliers in the data set when we compare different variables. Here we are comparing city population, is fraud, amount, customer age, and Unix time. And here we are comparing for the transaction year, transaction hour, zip, transaction long distance, and latitude. So we don't find any outliers in the data set. Now we'll check for the correlation with the help of heat map. Here we can see that merchant, merch lat, and lat, merch log, and long are highly positively correlated, whereas merchant long and zip are negatively correlated. So we can remove one of the columns for better analysis. Now I'll do the univariate analysis for the categorical and numerical column separately. So first we'll do the univariate analysis for two categorical columns, that are the merchant and job. Here from there we can see that the merchant fraud killback LSC mostly is a merchant that mostly accept credit card transaction. The people in film, video, editor and exhibition designer category makes maximum use of transaction by credit card. Now I'll go for the next analysis of other categorical variable. Here we are doing the analysis for the state and city. We can see that Texas state used the credit card for transaction for maximum number of time, and the people living in the Birmingham city do the maximum transaction through credit card among other cities. Now we do the unit analysis for another 4 columns. Here we are doing the analysis for the category, transaction month, transaction day, and gender. So as you can see from here, gas transport and grocery pros categories are the highest transaction dealing categories. The maximum transactions are done on Mondays and Sundays. This December is the month that has reported the maximum transaction, and the female do more transaction than male with respect, and this is all we are talking about the respect to credit card. Now we'll do the univariate analysis for the numerical column. As I can see that the most transaction done by credit card is of 1000 and very few transactions above 5000. The people of city with the populations 0.2 and 0.2 are doing the maximum transaction by credit card, and the people with the age of 35 and 45 do the maximum transaction through credit card. As you can see that another univariate analysis for columns such as Unix time, transaction year, transition are in zip, I can see that most transactions are between Unix time 1.35 to 1.36 and um, very few at 1.3539. The majority transactions are happening between 11 a.m. to 12 p.m. 12 a.m. midnight, and minimum transactions are happening between 12 a.m. to 11 a.m. in the morning. This trend shows that people do less transaction in the morning and more transaction in the afternoon and night. The city with zip code of 17,000 has the maximum number of transactions. There are, from another analysis, I can see that there are constant number of transactions at a latitude distance and longitude distance of 0.1 to 1.0. Okay. Now I'll do the bivariate analysis for the categorical and the numerical column. So here, from when we are doing the analysis for the category and month, day, and male, female, for the categorical variable, we can see that the maximum fraud transaction is reported by category shopping net. The month of February has reported the maximum number of fraud transactions. The fraud transactions reported for male are more than female. The maximum transactions are done on Thursday and Friday. If we do the bivariate analysis for the numerical column, we can see that the fraud transaction amount is more than the non-fraud transaction amount. If we check for the fraud transaction is same for both the years. The fraud transaction are more in the early morning, in the late night than non-fraud transactions. However, in the afternoon, the fraud and non-fraud transactions are same. The fraud transactions are reported at Unix time 1.34 at maximum. We have to do another bivariate analysis for the numerical variables. Here we can see that the fraud transaction and non-fraud are constant with respect to city population. The zip and the zip of the fraud and non-fraud transaction are similar. The people with the age of 60 have reported a maximum fraud transaction. The latitude and longitude of the transaction, the merchant are same for both fraud and non-fraud transactions. So we basically now created the dummy variable for better representation of the data. Now we have checked for the data imbalance. As you can see, before the imbalance, we can see that there is a huge imbalance in the data, and once we did the imbalance treatment, the data is more balanced now. Then we'll go for the model building. Here we have split the data into train test data set in 70 to 30 ratio. Train test using to train the model, and test is user test the test code. So as we can see that it's the data. Now we check for the skewness in data. As we can see, the data is highly skewed. So we have to fix this skewness for better result during model building. So we have done the remove the skewness in the data. Now the data is more suitable for model building. So here in model building, first we will be using the logistic regression approach. Here we'll be using RFE with 20 variables for building the model. Okay, so as we can see here, RFE in logistic regression, we have the measurement of the model such as where the sensitivity is 76%, specificity is 94%, precision is 93%, and F1 score is 84%. Okay, we are getting the optimal cutoff of 0.4%. That is okay. And now we have measured the now we measure the performance of the trained data set. As we can see that we are getting an accuracy of 83% on trained data set. Sensitivity stands at 82%. specificity at 84%, precision as 84%, and recall as 83%. So this is a good thing. So now like we have um, a measurement performed in the test set. In this test set we have an accuracy of 80%, sensitivity of 80%, specificity of 81%, precision of 81%, and F1 score of 80%. So which is a good thing for the logistics regression model. But now let's go with the next model building. Here we'll be building the model using decision tree. While building this model, we are getting a good accuracy of 98% on both train and trader set, and the sensitivity stands at 99% on train and 98% on test. Precision stands at 98% on train and 99% on test. So that's a good model. Now I'll do one more model to see if we can get a more accurate model than this. So when we build the model using random forest, we can see that we are getting an accuracy of 90% on train and test data set. The specificity, or you can say the recall, sets at 83% on train, and on test it is 99%, and the precision stands at 96% on train and 83% on test. So we are getting an accuracy of 90% on data set. That's a good thing. But here, after evaluating all the three models, we'll go with the decision tree model because it is giving a higher accuracy as compared to other three models. The accuracy of 98% and precision as 98% and recall is 99%. So that's a good percentage for model. So now we'll do the cost benefit analysis as I told you. After the model has been built and evaluated with appropriate metrics, we need to demonstrate its potential by performing a cost benefit analysis which can be presented to the relevant business stakeholders. To perform this analysis, we need to compare the cost incurred before and after the model is deployed. Earlier, the bank paid the entire transaction amount to the customer for every fraud which accounted to heavy loss to the bank. So we'll perform the following calculation specifically to arrive at the final saving that your model can potentially provide to the Phoenix. So current loss incurred is basically, in here you can see that the average number of transactions per month is 77183.1, average number of fraud transactions per month is 402.12, and average amount per fraud transaction is 530.66, and cost incurred per month before the model was deployed is 213389. Okay, so analysis after the model building. So after the model building, we can see that every number of transactions per month detected as fraud by the model is 31890.62. that is a good thing, and as compared to non-detected. Then we'll check for the cost of providing the customer executive support per fraud transaction detected model is 1.5. Total cost of providing customer support per month for fraud transaction detected on model is 4799.7.12. Average number of transactions per month that are fraudulent but not detected on model is 233.29. Cost incurred due to fraud transaction left undetected the model is 3797.6. Cost incurred per month after the model is being built and deployed is 171794.79. So the final saving is 41467.06. That's a good sign. Now let's have a summary. In the summary, we can say that the male are more prone to fraud transaction, and people do more transaction from 11 a.m. to 11 p.m. The fraud transaction generally happens in the later night. The maximum fraud transaction happens on Sundays and Monday. December reported the maximum number of fraud transactions. People within the age of 50 to 60 are more prone to fraud transactions. For this, we can see we have three important variables: the amount, category, and gender, that are very crucial in the model building. And we can see that gas transport, grocery process, and shopping has reported the maximum number of fraud transactions. So conclusion. So we can conclude that a fraud transmitted model is more than the fraud undetected model. As you can see, the average number of transactions per month detected by model is 31890.62, and as compared to not detected is 233.29. The cost incurred after the model is less than cost incurred before the model. As you can see that the cost incurred before the model was built is 2133.89. After the model is built is 171,794.79. Yeah, so that is a good thing, and we are saving with this 41594.291. So the conclusion and recommendation. So we have used the tree model with accuracy of 98%, precision of 98%, recall of 99%. We will be using this model because of its high accuracy among all the three models. To perform the cost benefit analysis, this model is best. The model detects highest number of fraud cases, the model is cost effective, and the overall model seems to be good. So for this, I have attached few files that I've discussed, that is a raising fraud root cause analysis, structured problem solving, cost benefit analysis, credit card fraud detection, fraud train fraud test, video presentation. So I'll actually walk you through my code that I've used for this model building. Here in this first, I've imported all the necessary libraries required for model building, and I have import warnings so as to ignore the signs warning message we get while building the plots. And I've used 3000 columns for more detailed analysis. Then as I told you, like I first have imported the train data set, then the test data set, then after that I have merged the train and test data set into a single data set. Then I inspected the data set and just suppose a warning to suppress the scientific notations. Then I do the describe of the data set. Then here I try to find the fraud percentage of the data set, that is 99% and 0.52%. Then I did the data cleaning. Here first I to check the null values, then I did the conversion of data types, then I have done the creation of new columns, and I've taken this column to find the distance between the transaction and the merchant. Then I have did the billing columns for age, for amount. Then after that I have segregated the column into categorical, numerical and credit card categorical columns. Then I check for the value count in the data set. Then I have checked for the amount, thus plot the graph for the amount range to see which amount has maximum transactions. And the same I plot the graph for customer age group. Here I can see that the maximum transaction are the people of age of 50 above. Then I'll check for the gender. Then you can say female are doing more transaction than male. Then for the category, you can see that travel cash transport is having the maximum transaction, and travel category has low transactions. The day, the Monday has more transaction than Wednesday minimum. Then I check for the transaction month. December is reporting the maximum number of transaction. The number of transaction is same in both the years. As you can see here, later in the evening and afternoon, we can see the maximum number of transaction happening. And I've checked for the merchant count, value count, state counts, city counts. Then I check for the outliers. I can see from here there are no outliers in the data set. Then I check for the data imbalance with the help of pie chart. As you can see that there's a huge imbalance in the data. Then I use the heat map to check for the correlation among variables. I can see that transition month and units time and merchant long latitude and merchant and are highly correlated. Um, then I remove the highly correlated variables. Then I did univariate analysis for the numerical columns. Then I did univariate analysis for the categorical columns. Then I'm doing the bivariate analysis for the numerical columns to draw some, and categorical columns to draw some insights. This is the insight I've written. And then I've checked for the distribution of transition amount by fraud and non-fraud categories. This is the insight I've drawn. Then I've created a dummy variables. Then I checked the shape of the dummy data set, and then I did the binary mapping of the genders. It's part of dummy thing. Then I removed the dummy variables that are not required for model building. Then I anticipated final data set. Then I'll check for the distribution of data. Then after I checked for the balancing of the data. As you can see that there's imbalance in the data. Then I use the oversampling technique to perform the balancing of the data. After performing that, I can see the data is balanced. Then I use this balanced data to perform the train test split. I have created train test data set and test data set. To the shape of the data set, then I check for the skewness in the data set. The data is highly skewed, so I have run the power transformer to reduce the skewness in the data. This is the data after skewness. This treatment is done, the skew data, and after that I perform the standard scaling to scale the data, and I build the logistic regression model. Here I am using RFE technique for the model building, and this is my model, and I fitted the model. And I can see the optimal cutoff. Then this is the plot with the optimal cutoff, and I've done the evaluation of the model of the trained data set. Here I'm getting 83% accuracy. For test I'm getting 80% accuracy. Then I use the dysentery model with the hyperparameters using max depth, min sampling, critical entropy, and gauge Gini. Then I use the grid search CV. Okay, I have created the train test data set. Then this is a grid search CV result. This is enlarged result. Then after that I done the evaluation of the model on the train. I can see that I get 98% accuracy. On test I'm also getting 98% accuracy. That is a good model. Then I have done the random forest for model building. Here I have just fitted them. Then I've used the max number of students as 10, maximum as 4, max feature is 5, 42, and order of source is true. Then fitted the model after getting the copy of the trend data set. Then the out of box score is 89, number of students is this thing. Then I can run the train and test data set, train and like check for the accuracy of the model. On train I'm getting 90%, and test I'm getting 90%. So out of all this I can say that dysentery is getting 98% accuracy. So this is the best model for cost benefit analysis. Then for the cost benefit analysis I merge the create a subset from the non-predicted trained data set. I create a predicted data set, and I merge the two data set, and I created the final train model, and I check for the fraud count and non-fraud count. Then I created a subset of non-predicted data set, on train. Then I created pilot train model. Then I did for non-predicted test count. Then I merged the model. Then here I perform the cost benefit analysis. I check for the average number of transactions per month, number of fraud transactions per month, average fraud transaction per month, average amount per fraud transaction. Then I check for the cost incurred per month before the model was deployed. It is this thing. Then I check for the average number of transactions detected as fraud by the model as this. Then this is the cost providing executive support per fraud agent. My model is 1.5. So total cost provided providing customer support for fraud transaction model is 479. This the average fraud transaction per month that are fraud not detected model is 233. As you can clearly see that is less cost incurred due to the fraud detection undetectable model is this 123797. So cost incurred per month after the model build is this much. So from here we can see that we're getting a final saving of this amount. From here we can see that in conclusion we can say that the transaction amount, these are more important variables. This grocery for shipping is the top category available. The males are more prone to transfer transactions. People are to more attention between 11 a.m. to 11 p.m. So we have built a model using Dysentery and do the cost benefits because it is more accurate and it's getting a good result. And this is our credit card cost benefit analysis table. So here we have represented in a tabular format for better analysis. So that's the end of my presentation. I hope you like it. Thank you for watching.